All right, so let's start. Thank you everybody for attending this presentation. Well, my name is Francis Saya. I'm an architect and product manager of VisualARQ. I hope you enjoy this presentation where we will see an overview of the main features VisualARQ adds to Rhino, the main flexible BIM features that we will explore today. And I would like to explain what does this term of flexible BIM means in terms of modeling architecture inside Rhino. First of all, I would like to launch a poll just to have a little bit of your background. If you are so kind to fill it, it's very quick. And well, you will see that I would like to know if you already know about Rhino, VisualARQ, Grasshopper, or how did you get to know about this webinar. So if you can answer it, I will appreciate that. And I will just give maybe a few seconds you to go through it, and we can start. Okay. There is one question where I would like to know which are the most interesting features for you that you would like to see. So I'm seeing that there are very different opinions. It's very distributed, the interests from what you are answering so far. So that's good, because we will cover most of these topics, and I hope that nobody gets frustrated if we don't mention any of them. So don't worry, we'll cover these aspects of VisualARQ. All right. All right. So yeah, I'm gonna stop the poll, and we can start. So let's go. Well, first of all, VisualARQ is developed at Asuni. So we are a company based in Barcelona, in the same office as McNeil Europe. Actually, we belong to the same group. And we also develop Lands Design, which is a landscape design software that works on top of Rhino, but also on AutoCAD. Okay. But today we are here to talk about VisualARQ. So what is VisualARQ for? I'm going to highlight the three main topics, the three main purposes of the program. First, the aim of VisualARQ is to produce BIM models inside Rhino. As you may know, Rhino itself, it's not a BIM software, but thanks to VisualARQ, we can make it a BIM software, okay, with the tools that VisualARQ adds to Rhino. Secondly, VisualARQ provides the tools to produce all the 2D drawings from a 3D model in a way that they are linked to the 3D model. Okay? So all the information and 3D drawings because it comes from the 3D model. And finally, VisualARQ also provides the option to exchange Rhino models with other software through the IFC file format, that, as you may know, is the standard format for exchanging BIM models within AEC applications in the market. So based on these three main purposes, I'm going to highlight the main features of VisualARQ. First, I'm going to mention those related to 3D modeling, then from 2D documentation, and finally, those related to IFC features. So first of all, VisualARQ provides a set of architectural objects. They are all parametric. That means that we can change their dimensions through parameters very quickly through the properties panel. And they have some associations, so doors, windows are attached to walls or curtain walls, so it's easier to model them. And also, they have a 3D and a plan view representation, so we can either work in 3D or work from a plan view, where some objects have a specific plan view representation. On the other hand, we have some navigation tools that makes it easier to work with architectural models in Rhino. For example, the level manager. This is a kind of a panel that lets us add new levels, and each one places an elevation plane, construction plane at a specific elevation. So we can switch from one level to another just by clicking on the proper level. And also we can hide levels as if we were activating clipping planes. So it's quite user-friendly to visualize the model with through one specific level, not only in plan view, but also in 3D. And actually, if we show it from the top viewport with a cut plane activated, all the objects show this plan view representation. In a similar way, there is the section manager. Let's just show a list of section lines that, unlike Rhino clipping planes, they can be juggled. This example. And we can also navigate by switching one section or another, or we can align a specific section to a viewport, so that's ready to be printed or to work from there directly from the 3D model. So, sorry, I skipped one slide. So related to documentation tools, VisualARQ adds the hidden display mode that lets us print whatever we see in 3D directly to vector. As you may know, if we want to print something in Rhino and we're using, for example, a shaded display, we can only print that as a raster, raster output. We need to to switch to a hidden mode, which is a display mode provided by VisualARQ, if we want to print that what we see directly to vector output with a 2D quality PDF or print result, right? So this is very useful for producing architectural drawings, because when we have an architectural model like that, it's just a matter to show the plan view in a specific page layout, make sure we're using this hidden display mode inside it, and just print that to a layout of the PDF. In the same way, we can do that with a section. So we prepare the section view into a specific detail view, and as long as we use this hidden display mode inside it, we will be able to print that. Another way VisualARQ provides options to produce 2D drawings is a similar approach as Rhino's Make 2D, which is the two options to produce 2D section views and 2D plan views. These are commands to produce that generates some blocks in the model space that, unlike the Make 2D tool, they are linked with the 3D model, so we can update these 2D blocks, and they will recalculate all the changes done on the 3D model. We'll see some examples of that later as well. And also related to the drawings and the attributes of the geometry, especially when we show them in section. So VisualARQ provides section attributes that works either on VisualARQ objects, but on Rhino geometry. So we would have the entire model created to Rhino geometry, and just by assigning section attributes, line weights for the sectioned contours, and by showing the model in section, we could produce interesting architectural drawings. Okay. And then, well, finally, the feature that VisualARQ allows you to change Rhino models with other software in the AFC industry is the IFC connection, IFC file format. That since VisualARQ has architectural objects, they are identified in other programs when we export the models to IFC. Okay, so walls will be identified as walls in Revit or in ArchiCAD or in other programs, as well as columns, beams, openings will be identified as such in the other programs. Okay, and not only the object type, but also the information stored in the 3D objects. Okay, so these are all stored in the IFC files. And of course, in the Rhino model, we don't only work with visual objects. We can work with very complex shape, very freeform piece of geometry, and still we can select it and tag it with specific data. For example, we can tell this polysurface that is a slab with this IFC tag feature. So when we export that model to IFC, it will be identified as a floor or as a slab in Revit or ArchiCAD in this case. And not only the IFC type, but we can feed geometry with any custom data. We can create new custom parameters, and the values that we assign to this object, they will be stored as IFC properties. Okay, so you can feed geometry with data that will be retained in IFC files and read in other programs. Related to documentation, also VisualARQ provides this table command. So all the information stored in visual objects can be listed in tables, and we can customize these tables showing any property, but also these custom parameters that we can create for the document or for the objects. Okay. All right. When we talk about this flexible BIM concept, we want to break with this idea that BIM kills the creativity, that we need to select one model of a window or another. So we want to break with this and provide flexibility, but still working with BIM technology, right? Basically, managing geometry with information and well, keeping all this linkage between the geometry and data. So first of all, since VisualARQ works on top of Rhino, and you know that it's capable to create any freeform shape, so we can also produce BIM objects from freeform shapes, right? So we can create roofs from surfaces and extend walls to these surfaces, or as we have seen, we can tag Rhino geometry with data. So we work all the time with freeform objects, but with data. And on the other hand, this flexible BIM concept comes from the fact that how VisualARQ integrates with Grasshopper. And we can talk about two types of integration. On one hand, there are these Grasshopper styles. Basically, there are objects driven by Grasshopper definitions. And on the other hand, there are the VisualARQ components available in Grasshopper. So we can integrate all the VisualARQ objects inside Grasshopper to get them involved in all our scripts and Grasshopper definitions. If we take a look at this first integration, the option to create objects from Grasshopper definitions basically is a way to produce new objects that well, use a Grasshopper definition in the background, but what we see is all the parameters inside the VisualARQ dialogs. Okay, so at the end, we can use these Grasshopper styles even though we don't know Grasshopper. It's very interesting for people that maybe it's not skilled in Grasshopper, but they can take advantage of this technology. This summarizes a little bit this process. So we've got, for example, we start with a Grasshopper definition. Let's see this. Place. We start with a Grasshopper definition that produces piece of furniture like this one. Can be any object actually. So there are some parameters to change their dimensions, and then we create a new style, a new furniture style for this object, selecting that definition. We have all the sliders, all the parameters now in VisualARQ dialogs, and we can insert that object and change those parameters from the VisualARQ dialogs. Okay, so at this point we can use this object that uses Grasshopper in the background, but we can edit it as any other object parametrically without being aware that the Grasshopper is there, right? I will show some other examples later on. So you will see a little bit more the process. And of course, with this technology, we can have one object style and one furniture, in this case, that can have multiple copies and each one with different dimensions. Okay? They are all parametric and provides totally freedom to create custom parametric objects. And actually in Food for Rhino, there is a section where you can find these styles that, well, people share. Okay, so I also encourage you to share yours if you want to develop some in the future. Well, then we talk about the second integration of VisualARQ with Grasshopper. Basically, we have all the objects available there, so we can get them involved into our design, parametric designs in Grasshopper. And there are different types of components. For example, we have components to create new objects, like this one that generates a wall. Basically, a wall is generated from a path curve. Okay, and we have some additional options to tell the style of the wall, the height of the wall. Okay. Then we've got some other components to generate the styles. Basically, styles are the features that define visual objects. For example, in the case of a wall, the styles determine the number of layers or the thickness of each layer. And we can also create them in Grasshopper. And then we've got the components to deconstruct the information of visual objects. So From a reference wall, we can obtain the path curve. We can also obtain the head, the style, the alignment, and we can also obtain the information of the style, how many layers a wall has, the thickness of each layer, and so on. And of course, this is just an example of what we can do. We can create tower created with slabs and columns, parametric tower, or we can reference a roof in VisualARQ and generate all the structure inside it with beams. All right, so we can do many different stuff. Also, for managing data on geometry, could be a very quick process to do it with Grasshopper. If you want to name all these columns from 1 to X, according to the number of columns that we have, just with a few components, we can assign data to those objects. Okay. And also, with the VisualARQ components, we can also get them involved with the Grasshopper player command. So as you may know, this Grasshopper player lets you run the Grasshopper scripts, and just by following the steps in the command line, we can produce stuff in Rhino. So with Grasshopper player, we can also use definitions that are involving VisualARQ objects, okay, like this one that generates all this structure out from a volume. So we give the column span in one and the other direction, and everything is created at once. And also in the next version of VisualARQ, the next 2.13 version, it will be possible to reference VisualARQ objects or run geometry with this Grasshopper player, and we can embed that into different commands. So for example, we can create a command that is actually missing in VisualARQ, which is a kind of a match properties, match section attributes in this case, from one object to another. Also, the Grasshopper components will allow us currently to communicate VisualARQ with Revit through the Rhino Insight technology. As you may know, this technology is well, it's a plugin for Revit that lets you run Rhino and all the plugins inside Rhino as plugins for Revit. So what we're seeing here is Rhino and VisualARQ now running as a plugin for Revit, and Grasshopper is now in the background, is in between, collecting, referencing all the VisualARQ objects and transforming into Revit elements through a Grasshopper definition. Okay. And the idea of this workflow is that we can use Rhino and VisualARQ as a modeler, but we can have the model directly in Revit automatically generated. All the styles and objects are reproduced as Revit families with this hidden definition, Grasshopper definition, that now is running in the background. And I'm going to show very quickly this process with this easy example. We've got now VisualARQ running and Grasshopper as a Revit plugins. And with this component, I'm referencing all the walls from this model, and I'm deconstructing them so I can obtain the path curve of these walls, and I can obtain some other information with the deconstruct option. And thanks to these Revit-aware components in Grasshopper, now I can create a wall in Revit that requires a path curve, which can be obtained from this deconstruct wall. I connect this to the Revit wall component, and I've got all the walls generated automatically. And of course, I can assign head and all the head from those other walls, so I can put them into Revit walls. And with this workflow, we can have everything immediately modeled in Revit. And just another example of this technology. Actually, we can create buttons inside Revit that runs Grasshopper scripts. And if these scripts already reference all the visual objects and transform into Revit models, we just can hide Revit, work on the 3D model in Rhino, and just push this button to have everything updated in Revit. Okay, now I would like to show some user projects. Okay, it's just a selection depending on the different ways people are using VisualARQ. First, we've got this group of people that use VisualARQ for 3D modeling, producing 2D drawings with the VisualARQ object, although not everything is created with VisualARQ objects, of course. This is Basilica in Croatia. Or, for example, this office in geometry.fi in Finland that participated in the design process of this liver skin project in Tampere, the Nokia Arena, and they designed the facade of this arena and produced all these pieces of the facade with VisualARQ beams, and they could name them, and that was useful for the fabrication drawings and also for exchanging them out to IFC. And of course, especially in the conceptual projects or student projects, where it's very important the visualization and production of two drawings very quickly, VisualARQ also involved. This is the project that won the student contest that we launched last year, and it's very nice. And all these drawings and videos were produced with Lumion. That's a nice example. Well, we are seeing also people using VisualARQ in historical BIM projects. For example, those that need to scan existing building and they need to reconstruct it with 3D. So they need to deliver a BIM model out of a 3D scan. Or, well, then we've got people that only use the 2D drawing, the 2D documentation tools of VisualARQ to produce the drawings of a project, even though there is no single VisualARQ object like this case here. Or in projects of totally different scales, like this mailbox design, that also VisualARQ was used to produce all these elevations and sections of this mailbox. And finally, the IFC. VisualARQ is very used to enrich IFC files by managing all the data stored in the 3D geometry, either in Rhino or in Grasshopper, and well, creating new stuff, new complex geometry, and finally exporting back the model to IFC with all the revised data. Okay, just some value facts. VisualARQ is available for Rhino 5, 6, and 7. We are working on VisualARQ 3 already. I hope that it's we can launch it end of this year if everything goes right. And well, there is a 90 trial day, and like Rhino, there are educational licenses available, fully functional, can be used for professional purposes. And of course, we base our development on users' feedback, so we appreciate any feedback and suggestion. Okay. Also, there is an API available, so we actually in the next version we're gonna expand all the functions for the Visual API. All right, today we'll see well, these key features and that we have seen in this presentation, but we'll see also some basic workflow of VisualARQ integrated with Grasshopper, okay, or managing data on Grasshopper. And if there is time, we will see some cool examples. All right, so let's go to Rhino model. By the way, here with me there is Alfonso Melero, who will also help you with any questions you may have. So feel free to use the chat box to launch any questions, and we may eventually discuss them if they are involved, or maybe at the end of the session we can also talk about them. So well, here I've got a 3D model. This is the famous Villa Savoie. It's almost completely created with VisualARQ, and the first thing I would like to show is how to work with the level manager, because this is a very useful tool that not only if you work with VisualARQ objects, but with any architectural project can be very handy. By the way, maybe I may do an overview of the VisualARQ main toolbar. So we've got first the toolbar that lets us create VisualARQ objects. With the left click, we insert new object. With the right click, we open the styles dialog for each object type. Okay? There are some edit tools command. Keep in mind, VisualARQ objects are blocks. They are Rhino blocks. So there are certain commands in Rhino that don't work directly on them. So we need, for example, VisualARQ, it's their own commands to do, for example, Boolean operations or subtractions, okay, or to split direction or fillet objects. They need their own commands to do similar the commands that we find in Rhino. Then we've got some documentation tools for creating annotation, calculating areas, this table command that we have seen, tags, sections, opening elevations. these are the two commands to produce 2D drawings in the model space. And these two are those that open the level manager on one hand or the section manager on the other hand. Finally, we've got some additional tools to select objects by type, okay, or create custom profiles that we can use on columns, railings, or other objects, beams. Okay. All right. So yeah, let's take a look at the level manager first of all. Here in this project, we've got a building with 3 floors. Each floor has a construction plane at this specific elevation, so we can change that value. And this basically will create a construction plane there. So if we are working on the ground floor, everything that we draw, as long as, of course, we don't snap onto other edges, will be created on that level. Okay. If we now click on the terrace floor, now everything will be created on that elevation. Actually, if we see this model from the side viewports, we see the reference elevation marks or level marks to have a better idea, the elevation of each level. And we can add new levels, by clicking here. By default, they are 3 meters above, but we can also type any other value. Okay. I'm gonna delete this right now. Also, we can show and hide levels very easily. So if we were activating clipping planes, as I have explained before, so when I hide the terrace floor, everything above this elevation hides, and this lets us see the project from the inside and work from here directly. Okay, so it's very useful also for visualization purposes when we just want to show a nice render or screenshot of the model from here. Also, each floor has a cut plane, which is activated from this icon. So the cut plane basically is calculated from this distance related to the level's elevation. It's a distance that we usually cut through all the doors and windows. So when we have this cut plane activated from the model displayed in the top viewport, then this plan view representation of objects is displayed. Now, we do double click also as a shortcut to show one level or another. And when we activate the cut plane on this first floor, you will notice that since we cut through all the doors and windows, we see this 2D graphical representation. So we could keep on working from this plan view and have the feeling that we are working in 2D, but we are actually working with 3D objects. As soon as we rotate this, we orbit this 3D model, okay, we see that we are working with 3D object, and actually this plan view arc disappears. Okay, we can put this back from top viewport with this icon here. And also there are some interesting features. For example, we can double click to show one level or another. Now we do double click on the ground floor. We can also use this icon to display the plan view of levels located on other elevations. So we know that here we've got, on this corner, we've got a wall on the first floor. So we want to place a column. And we can also display more than one level projected on the ground floor with these tools here. But basically for navigation, it's very, very useful. All right, and in a similar way, we've got a section manager, so we can create new sections. Basically, we select a section style, and we just go through we just draw this section line as if we were drawing a polyline. Actually, I'm going to disable this. We can draw a section line that goes from that point to another. We need to specify a viewer direction and a depth. So the depth will determine the objects that will be included in the section. So now we select the section line, all the objects here will be drawn in that area. It will be displayed all in that area. So when we activate the section, and if we draw something that maybe it's partially inside it, so we just see the part that is inside that area of the section line. And we can also create jogged sections. basically, in the same way that we create a section line, we just need to do like a jogger line. Yes, we can call this section 2. And now we can activate this section, select the section line, and we can also play with the grid points. Okay, so we can select this grid point and put maybe here. All right. Okay, so all right. Now, these tools, these navigation panels also have some tools to align certain plan views or section views to viewport. So imagine that we're already working on the layout of this project. As I've mentioned before, as soon as that we use this hidden display mode inside the detail, we are able to print that directly to vector output. So we can print this view, select the vector output, and this will produce a 2D quality vector line. All right. And but we can also show in this model view a specific section. So we select this section 1, click on this button that will align that section view to that detail. And we might need, to select the detail and adjust the scale of it. So here we will just need to add all the title blocks and corresponding annotations to have that ready to be printed for producing the 2D drawings. This is a real-time version of the 3D model. We can click on here and work on the 3D model. Okay, so of course, that means that any change we do on the 3D model will appear in that page. All right. Yeah, and a similar way that we can create plan views instead, it's by selecting the floor that we want to draw and clicking on this button, and this will activate the plan view of the ground floor and will align it inside this detail. I need to edit the detail, go inside it, and now select this button. Okay. In future versions, the floor will also have a boundary. So this orientation will also take into account that boundary to fit that plan view into. Okay. All right. Let's move on. Let's take a look at how to work with visual objects. Of course, I don't have time to go through all of them, but you will see that once you learn how to work with one, the rest is very, very simple. So I'm working on the plan, the ground floor. So maybe I'm gonna work in plan view, and I can draw a wall that goes maybe from that point to another. So I need to first select here the parameters I want, the style of the wall, the alignment options, okay, or any other detail, for example, height. And now just draw a wall that will intersect with the walls and will clean the intersection. Okay. We can also create these walls from curves. Imagine that we have here kind of an arc curve, for example, something that does this. And I mean, there is the option to change the path curve of this wall, but I can also create it from scratch. And here I've got a command to create a wall from the curve. So I need to, again, select a style and some other parameters, select this curve, and insert it into the model. Now I can insert doors or windows inside it. For example, I can insert a door, and it's the same process. I have a list of door styles. So I select the desired one. I have here some parameters, for example, for the profile. I can select any of these predefined sizes, but I can also select other and just put any profile that I want. The door will detect the wall path and will snap into it and generate the opening. Okay? If I drag this door into another position, the door will find the path curve of the wall and will snap into it and produce the opening. If I have that door in a distance that doesn't recognize the path curve, it will just keep on floating on the model space. Okay, and so we will appreciate it was heard from here. As soon as it detects the wall, it snaps into it and produces the opening. Some other details, for example, walls have control points. So we can select these extension arrows to to stretch one wall in one direction or another, or can I select this point and stretch it in any other position? Okay. And mostly all the visual objects have control points that can be used to edit them in a similar way that we can edit curves and or surfaces from control points. All right, we can now take a look at the styles. I'm gonna create a new wall style, all right, because in VisualARQ templates, if you open a project from a new document, you can use a VisualARQ template where you will see a library of existing styles, but you may want to create your own ones, isn't it? So, this is the styles dialog of the wall object. And here we can see the list of existing styles. We've got this exterior 100, exterior 200 millimeters. If we expand this arrow, we will be able to see the different layers. They are the components of wall styles. And just by selecting each one of them, we will be able to edit their features. We can change the thickness from here, or we can change the attributes. For example, the material, the layer, what it is assigned, visibility. And we have either here the attributes in section or the attributes in projection. We can also see this, for example, from in plan view. Okay. But let's create a new style. So I'm gonna, there are different ways to do this, like this icon here, or just by clicking this new button that will launch this wizard. I'm gonna do it simple, just call it new, say that we want a 3-layer wall, and click next. We need to define the name and the thickness of each layer. I'm just gonna create a very simple 3-layer wall style. Click next, and once it's done, we've got it here listed next to the other styles. Right now, we can expand this style, select each one of these components, these layers, and for example, we can assign as solid hatch pattern for the first and the last component. Click OK. Now we can just select, for example, this wall. We go here to the properties of the object. A wall is detected, so we can now change any parameters of this object. For example, the style, and set it to new. So we can see this new wall here, right? So you can create on new styles. You can actually create them and store them in a template that so they are available every time you start a new project. But let's explore new possibilities to create object styles. For example, in the case of doors or windows, there is the option to create objects styles from blocks. Okay? Because as you may see, the level of detail of visual objects is very simple. Okay? They are aimed to, well, let's say to create quick drawings with simple objects. So they are also lightweight objects. But you can make them very, very complex. And one of the options is to create them from blocks. Okay. If you explore the door style properties, we have this hinged. Actually, this is the hinged glass. It's this one, right? And well, we can see here some default parameters. For example, we have the frame here, and again, here we have all the features to edit this frame, the lift. We can select the glass. Actually, it's kind of a a tree structure where components depend on other components. And for example, there is the option to add some divisions here, some mountains. But well, if we want to assign a more complex door, here we would need to select this style, go to the blocks tab, and here use a 3D block that we have imported into Rhino, or we have modeled in Rhino, and use it as a 3D representation for the door. It will replace this representation. Okay. Or we can also do the same for the plan view. So instead of a simple, 2D arc swing door, we can use a more detailed 2D door for the plan view representation, regardless of how this door looks in 3D. But here, maybe the most interesting option is to use the option of a grasshopper style. So when we create a new door style, you can see that we've got the option to create a regular one, but we've got also this grasshopper style. So I'm going to show you an example before clicking this button. I'm going to show an example of a grasshopper definition that generates a bifolding door, which is a kind of door type that it's not possible to be done with existing parameters for the door styles. Okay, so I'm gonna show this definition and show you the process of converting a grasshopper definition into a VisualARQ style. So okay, I'm gonna use this model. You can see here the preview of what grasshopper generates, and this is the definition. Basically, we've got some inputs that control the width and the height of the door. Okay, we have parameters for everything that I wanted, also for the aperture, all right, the number of leaves, and so on. Okay, they are blind or glazed leaves, etc. So basically, we have a list of inputs that will become the parameters of the object and the style. But on the other hand, we have here some ending geometry params or curve parameters that will be identified as the components of the new style. So that's why I have breaking them down into different parts, like one for the frame, another for the leaves, glasses, okay, and so this is the curve for this opening direction, right? So I decide which level of detail I want to put into this definition, and later on, I'm going to just play with the parameters in the final object. It's important that to be aware that we need to name these components accordingly. Otherwise, it will be difficult to identify them when we create the style. And if we don't have this connected, I mean, this is not going to be identified by VisualARQ. We need to connect them into a geometry params that are not further connected with anything else. Okay? So that's what VisualARQ will identify as a part of the new style. So I save this definition. I can close Grasshopper now. I go back to the door styles dialog, right click, and now we can select this option, Grasshopper style, where I will look for this definition. So that's the default door, right? Click next. The first thing I need to do is, of course, define the style name and definition units, but first I need to select which one of these ending geometry params is going to perform as the opening profile. So I've got one rectangle that was for that purpose, and this will be the one that will determine, the cut of this door into a wall. I click next, so I can decide which components I want to import, and I also can have components that are used only for the plan view representation. And finally, here I have the list of all the rest of parameters. So I decide which of them will be parameters that I can edit by object, like the width or number of leaves or the height. Also maybe the aperture, right? And actually this aperture can change the type into a percentage. And I can also leave the other parameters as style parameters. So I will only be able to edit them through the style dialog, and any change will affect all the doors of the same style in the model. Okay. And actually, there is another option here, for example, the leaf type. By definition, that means that I won't see this parameter if I set, parameter editable definition. This will be hidden from the VisualARQ dialog, so anybody will be able to edit them. I click finish. Now I've got this door style as a new style in my list, in my library, and since I collected the different parts into different components, I'm now able to assign different material to each one of them. So the glass, of course, will take a glass material. Okay. And now, all right, I can insert that door. Maybe we can insert into the first floor. I'm gonna delete this door. So instead, I'm gonna insert this default door. Right? There is also this option to measure, the distance of a specific parameter, like the width. So I can make it until this point and insert it in the model. And now I can select that. I can go to the properties of this door, and I will be able to edit here the parameters that I decided were editable by object. For example, the aperture, set it to 80%. All right, and I can have a copy of this door next to it. Okay. Well, sometimes you need to make sure it's close enough to the wall so it generates the opening. And in this case, I can change the aperture to a different value. So both objects are using the same grasshopper definition, which is running in the background, but each one of them can have different parameters. All right. Okay, let's move on. Let's see some of the documentation tools now. So we have seen already how to produce the drawings in the page layout using this hidden display mode, but also we got these commands that, as I mentioned, they are similar to Rhino's Make 2D that might be eventually useful because, especially if you want to export to the drawing to DWG, that's the only way to do that. So, for example, this section view command will select a section view style, then a section view, section line, and now we can insert that in the model. Okay. As you can see, this produces a block. This is a block of a section view that is linked with this line. Okay, so if we change the position of this line, maybe we put it here, then we can select this section view, update it, and it will be generated with a new position. Or if I draw new objects, maybe this section view actually should include that. I need to select now this view, click on the update button, and the new object will appear here. Okay, so we can explode it, of course, and it will lose the connection to the 3D model, but then we will be able to export that as a DWG file. And actually, we have full control if we explode it on the different lines and hatch patterns generated here. Also, the attributes of these lines are related to the attributes of the 3D models they represent. So if I had the layer walls, they will hide either in the 3D model, but also into this drawing of the lines that are linked with these 3D objects. All right, like this, and maybe we can see the table commands. Okay, we have seen that we can list information of visual objects. For example, we can insert a list of openings. We need to select here all the objects that are already filtered, the object types that it references. And here we can see all the data from these objects. We can add, as I was mentioning, custom data to objects or visual objects. And we can do this from different ways. We can do this by object. So we can select this column, for example, and from this parameter section, we can click on this. But here, basically, we can see all the information, all the custom parameters on objects. And from here, we can create new parameters that will appear only for that object type, for that specific item. If we want to add it for the whole document, we can do it from the document properties. We have a shortcut here. So again, in this document, actually, this is the VisualARQ template. So it already comes with a few custom parameters, but I can add a new one called date of phase of construction. Okay. We assign it to a category. Category are nothing but ways to arrange these custom parameters. So they are grouped in the dialogues. and data type text. We'll click OK, and now we can select maybe all these windows. So we can select the windows of the same style. There is a command for that. Or with a context menu, we can select these windows, select all these windows of the same style, and now we can assign a phase of construction to all of them. For example, existing. Right? Actually, this rather than selecting all the models of the same style here, we can go directly to the window style. I'm gonna do that for a different window. Okay, for example, this one, and here we've got also the parameters with this phase of construction, and maybe I can call this new just to have a different value. And when I select any of these windows, maybe it's one of this one. No, not this one. Anyway, when I select this and of these styles in the model, we'll see here the value assigned. Okay. And if we want to display this value in this table, we go to the table styles. We expand the table styles for openings. I can add here a new property field that would be the phase of construction. And here assign the corresponding parameter. It's the last one from this list. Click OK, and now we'll see this information in the table. We can export the table to Excel, and of course, if we modify the value of any of the windows or rows we have selected for this table, the values will update in this list. Okay. All right, let's move on. Before showing something else about Grasshopper integration, I would like to mention that these custom parameters, as I was explaining in the beginning, are stored in the geometry. So when we export the model to IFC, these values will be also exported. Okay. For example, if you select that window, that column, we also assign here a value for the phase of construction. This value will be read in other programs when we export that column to IFC. And of course, all the objects are exported with the object type and they are. But what if we have a piece of geometry? For example, imagine that we've got some RAM here. Okay, we just do it with a Rhino polar surface, and we want to export that object as a RAM. Okay, this is actually a polar surface, but we can tell this to be a RAM from this IFC tag icon, and here we have the list of all the types, IFC types available. Okay, so we'll select this IFC RAM here, and this object will be exported as a RAM. We can also assign here a value for these custom parameters, like new, and also this data will be stored in that object. Okay. All right, some more stuff that we can do with the IFC options. Basically, all this IFC tag assignment can be managed by layer. So we need to go to the VisualARQ menu. We go to IFC export options, and here we have the option to assign these these types, okay, by layer. So all the polar surfaces or geometry that is not a VisualARQ object will take the corresponding IFC type if it has the IFC type assignment by layer by default. Okay? Which is the usual case when we draw something new. Okay, by default it goes to the IFC assigned to the layer, but if we change that, it will take the corresponding IFC type. And exporting a model to IFC is nothing but, go to File, Save As, and select the IFC file format. Okay, as easy as that. Okay, let's talk about some examples of the other way VisualARQ integrates with Grasshopper. So I was mentioning, we have seen, the option to create new styles, new object styles from Grasshopper definitions. Now we'll see how to involve VisualARQ objects in Grasshopper definitions. So we have here the VisualARQ components. So for example, we can create a wall from a curve. So we can have here a curve. I'm gonna make sure I work it from the ground floor. I'm gonna delete this table. So I'm gonna draw a curve in here. I'm gonna reference this curve. And this will be the path curve of my wall that automatically snaps into it and gets attached to it. Of course, if I want to change the feature of this wall, I put here a wall options component. And here there is some information missing, for example, the style. I need to do right click and set one style. And I can change the height, maybe to say one goes from 1.5 to 10 meters for the height of the wall. Okay. And now if I want to insert some windows in here, just need to maybe define a point on that path. Okay, I have already that path, but if I were referencing a wall, I could use the construct wall instead. That would give me the same path curve. So now I can use a point along this path to be the position of a door or a window. So we have here the window component that requires a host and a position. Okay, and well, I've got here some options, some window options. Of course, I can elevate this point, so it's not placed on the base. But with these window options, I can define more details for the window. For example, the style. I can select any of these styles, and for example, change the profile with another component, with a rectangular profile. And here just put some numerical sliders for the width or the height of the window. Okay, so if instead of one point I had a division of points on this wall path, of course, then now I will create a window on each one of these points. Okay, so as you can see, the workflow is very simple. If you already know how to work with Grasshopper, everything finds its logic. And maybe I can show you some more advanced examples of more developed definition, so you're aware of all the possibilities. Okay, for example, this is a definition that using a rectangular grid of using a rectangular grid, I place on all the intersection points some columns, and I use the boundary of this grid to generate the slabs. Okay, so with these components, I now have full control of this structural tower, where I define the number of columns in one direction or another. I can also define how many levels I want and the height of each level. All right. And once I bake all this stuff, I will have as a result, slabs, columns, or stairs in this case. Okay, maybe I have time for one last example of how to use these Grasshopper components to create, to enhance maybe some processes. For example, when it comes to produce all these 2D drawings in the model space, instead of generating, for example, imagine that we want to create two cross section and the four elevations of this 3D model. Just using a Grasshopper definition for that, we can have it for not only for this object, but for any other object. Okay. So I'm gonna show this definition that basically what it does is referencing all the VisualARQ objects with this pipeline component and Rhino geometry with this geometry pipeline. Through the bounding box, I can obtain the edges of this bounding box, and I use these edges to offset them and produce these section lines. On one hand, 2 cross sections. On the other hand, these 4 sections, 4 section lines, a little bit offset. So all these components are section and section views. They are available here in the annotation components. And if I pick either the section and the section view, once I have determined the position of these views, okay, as a result, I will get the 2 sections and the 4 elevations created at once with this, function. Yeah, here we are. All right. So, well, there are many things I could tell you. There are many examples where there are situations that you could get advantage, but this is the end of the presentation. I don't know if we have time for some questions. If there are, I will be glad to answer. Okay. Let me just take a look at the chat if there is some questions over there. Okay, there is a question about VisualARQ inside Revit. Well, it's right inside Revit plugin, is under development. So actually, the developers are using the Revit API to construct components in Grasshopper that are available to reproduce geometry in Revit, families, and other stuff. And VisualARQ just takes advantage of all this technology. Since we can deconstruct all the information of visual objects, we can obtain all the information that styles need to be generated. We can use that to produce the equivalent families in Revit when we work with Rhino, VisualARQ, and Grasshopper in Revit. So, yeah, VisualARQ just takes advantage of this new technology, and it's also another way to use VisualARQ and Rhino as a BIM modelers instead of having to do it in Revit direct. Okay. Okay, there is another question. Say from David. When generating the columns grid, there were not generated the floors layers. Is this possible to automate too? Yes, that's possible because if I open that definition again, I've got somewhere here there are the components to create the levels. Okay, and if I take now this building component, all this list of levels will be baked here as well. Okay, so yeah, there are also the components available to create multiple level building at once without having to enter them one by one. Yeah, thanks, Alfonso, because some of these definitions are available for Rhino or available online. Also, I will be glad to share them with you if you want. So just send an email to our contact support. I will be glad to share them. Let me see if there is a new questions. Yeah, there is a question about IFC4 from Clemens. IFC4 is expected to be included in VisualARQ 3, not in VisualARQ 2. So we are actually currently working on VisualARQ 3 version. And one of its new features will be the IFC4 support. Okay. Actually, well, this is just for you. If you go to the VisualARQ website, maybe it's worth it that I mentioned that. If you go to the VisualARQ website, if you go to features, there is a place here where you can explore the VisualARQ roadmap. And here you can see the features that most of the features that people are asking for VisualARQ, and you will see the status of each one of them. So you will see that many are in progress. That means that we are working on them for VisualARQ 3. And those that are in planned, maybe they will include some in VisualARQ 3, or they will be available in further versions. Okay. Yeah. Alfonso has shared our contact support in the chat, but from the website, you also need to go to support, and you will find our contact here. And also here, it's worth to mention that you have plenty of learning resources like webinars, video tutorials, some exercises to go through the Grasshopper components or Grasshopper styles. So there are easy exercises to learn this technology. Claudio is asking when VisualARQ 3 will be available. We don't know. We would like to release it by the end of this year, but everything depends on the amount of new features we finally want to include. Where we, cut this list, we say, okay, until here. So, but our goal is to release it by the end of this year, if everything goes as expected. As you may know, development is kind of unpredictable, so we'll see what happens. And there is another question about work sessions. And yeah, from Maria, VisualARQ supports work sessions. You can work with VisualARQ models and work sessions as you would do it with any other Rhino model. Okay, so yeah, there is this work sessions support. Another question about upgrading. Yeah, there will be option, of course, a special price for VisualARQ users to upgrade to VisualARQ 3. Okay, we still don't know the details, but it won't be free as it has been for VisualARQ 1 version users to upgrade to VisualARQ 2. But of course, it will be you will need to buy a new license. It will be there will be probably a special price for upgrading from VisualARQ 2 to VisualARQ 3 if you are already a VisualARQ user. All right, so thank you very much for attending this presentation. And yeah, feel free to share your feedback, your suggestions, or questions. So we will be always happy to help you. Okay, bye-bye.
Thank you very much.